let's solve some equations that involve the trig functions. Let's find t if t is between 0 and 2 pi and 4 sine t minus square root 3 equals 2 sine t. So we're going to solve this just like we would a problem in algebra with a variable of sine t. We just have one last step where we find t from sine t. So I'm going to start here by adding negative 4 sine t to both sides. So I'll add that to this side and also to this side. That's just my addition property of equality. I end up with negative square root 3 is equal to negative 2 sine t. I solve this for sine t, and I end up with sine t is equal to negative square root 3 divided by negative 2, which is square root 3 over 2. Now, I want all solutions between 0 and 2 pi, so I know that my sine function is positive in quadrant 1 and also in quadrant 2. So I know because sine t is equal to square root 3 over 2, I'm looking for a radian solution here, that my reference angle is going to be pi over 3. So I'm thinking sine of 60 degrees is square root 3 over 2, so my reference angle is 60 degrees or pi over 3. Now I want to find the angle in quadrant 1 that has this for a reference angle and the angle in quadrant 2 that has this for a reference angle. So t must be equal to, well, in quadrant 1, it's just the reference angle itself, and in quadrant 2, it'll be pi minus pi over 3, which is going to be 2 pi over 3. So if I was to draw a little coordinate system here, pi over 3 is the reference angle. In quadrant 1, there's pi over 3. In quadrant 2, it's going to be pi over 3 this way. That's pi over 3, so that must be 2 pi over 3. So t equal pi over 3 and 2 pi over 3, those are my two solutions to that equation. Solve just like I do a regular algebraic equation, just that I have one last step down here. I have sine t as square root 3 over 2, and with trigonometry I can find t from that expression. Now I want to find theta if theta is between 0 and 360, so I'm looking for degree solutions, and sine theta minus 3 is equal to 5 sine theta. So let's see, I think I'll add negative sine theta to both sides. I have negative 3 is equal to 4 sine theta. I'll divide both sides by 4, and I'll end up with sine theta is equal to negative 3/4. Okay, this isn't something I have exact values memorized for, so I'll change to a decimal, 0.7500. I'll use my inverse sign button on my calculator to find the reference angle. I'll input 0.75, work that out on the calculator. I get a reference angle of 48.6 degrees. Now I look back and see that sine theta is equal to a negative number. I want all values of theta between 0 and 360. Well, sine is negative in quadrants 3 and also quadrant 4. So I want the angle in quadrant 3 whose reference angle is 48.6, and I want the angle in quadrant 4 whose reference angle is 48.6. That tells me that theta must be, let's see, in quadrant 3, that's going to be 180 plus 48.6, which should be 228.6 degrees. And in quadrant 4, a reference angle of 48.6 is going to be 360 minus 48.6, which should be 311.4 degrees. So again, I'm thinking like this. From this expression right here on my calculator, I get a reference angle of 48.6. Since my sine function is negative, I know that theta must terminate in quadrant 3 or quadrant 4. So here's my 48.6 in quadrant 3. Here's my 48.6 in quadrant 4. So to find this angle, I take 180 and add 48.6. To find this angle, I take 360 and subtract 48.6. There's my 311.4, and over here is my 228.6. So there's how you solve one of these problems where you have to use a calculator on your last step to find the angle. I round it to the nearest tenth of a degree. Usually that's what we'll do. Let's look at another one. Here I want to find theta, again, if theta is between 0 and 360, and square root 3 tangent theta minus 2 sine theta tangent theta is equal to 0. Let's start by factoring out a tangent theta from both terms. Sometimes we have to do factoring just like we did in algebra. What's left in this term when I factor tangent theta out is square root 3. Minus, that's my subtraction sign. When I factor a tangent theta out of this term, what's left is 2 sine theta. On the other side I have 0. The only way I can have the product of two things equal to 0 is if one or the other is 0. So I'll say tangent theta is equal to 0. That will give me some solutions for theta, or square root 3 minus 2 sine theta is equal to 0. So tangent theta equals 0. This implies that theta is equal to, well, let's see, 0, and then I'm also going to put in 180 degrees because tangent is 0 at 180. Over here, this means that sine theta must be, well, I'll add negative square root 3 to both sides, then I'll divide by 2, square root 3 over 2. We just did that problem, so we know that this means that theta must be equal to 60 degrees. That's in quadrant 1, or in quadrant 2, 120 degrees. So I get 4 solutions to this equation, 0 and 180 degrees. That comes from tangent theta being 0. And 60 degrees and 120 degrees, that comes from sine theta being equal to square root 3 over 2. So there's 3 equations that involve trigonometric functions and their solutions.